Tässä esityksessä esitellään Akatemiasammon datapalvelua ja semanttista portaalia tutkimuskäytössä. Akateemiset henkilöt Suomessa 1640–1899. Olen Eero Hyvönen Aalto-yliopiston tietotekniikan laitokselta ja Helsingin yliopiston digitaalisten ihmistieteiden keskuksesta HELDIG. Akatemiasammon on osa laajempaa linkitetyn avoimen datan palveluiden ja portaalien sarjaa, joita olemme takoneet viimeisen 20 vuoden aikana. Käytetyin sampo on kirjasampo, jolla oli viime vuonna 1,6 miljoonaa käyttäjää. Myös toisen maailmansodan aineista julkaiseva sotasampo on ollut varsin suosittu yli 1 miljoonalla käyttäjällä. Sampojen aiheet vaihtelevat hyvin paljon. Meillä on biografiasampo elämänkerroista, nimisampo nimistöstä, MMM-sampo keskiaikaisista ja renessanssin käsikirjoituksista, löytösampo arkeologiasta, lettersampo kirjedatasta ja uusimpina sampoina parlamenttisampo eduskunnan puheista ja poliitikkojen verkostoista sekä lakisampo, joka julkaisee Suomen ajantasaista lainsäädäntöä. Katsokaamme seuraavaksi video Akatemiasammosta ja sen käytöstä tutkimuksessa.
I will introduce the Akatemiasammon data service and portal, and how it can be utilized for analyzing the lives of Finnish academic people in the Nordic and the Baltic countries. This representation consists of 4 parts. First one will be a general introduction to the project. Then I will talk about the source data, and how it was converted into linked open data, and introduce the resulting data set. The longest, third part of this representation will introduce the Akatemiasammon web portal. Finally, I will introduce methods for data analysis using the Sparkle endpoint. Akatemiasammon is a project conducted in the Semantic Computing Research Group at Aalto University in Finland. The project started in the year 2019 and was released in February 2021. The project is a part of Sampo series of portals and a continuation to our projects of historical people ontologies, such as War Sampo, Norsid High School Register, and Biography Sampo. The Finnish Student Register contains information about students of University of Helsinki, which originally was founded as the Royal Academy of Turku. Because for a long time it was the only university in Finland, we may say that the data contains most of the people with academic education in Finland between the years 1640 and 1899. Primary data and knowledge graph. In the source data each person has a semi-structured text description. The fields from that source data have been extracted using regular expressions. We have also utilized vocabularies of person names and occupations, and taking advantage of the possible, existing HTML formatting. The text description includes basic biographical information, like a person's name, his or her places and times of birth and death, and the occupation. In addition to that, the description contains academic events such as enrollment, being a member in a student nation, completing a thesis, and graduation. Furthermore, the description also contains information about a person's later career and related career events like employment. The description also mentions related people. When available, there is a list of a person's parents, spouses, and also other relatives who have studied at the University of Helsinki. Also the professor's or instructor's name is usually referred with the academic events. In total, the person ontology contains 28,000 students and 54,000 relatives mentioned in the descriptions. Machine learning methods were used to disambiguate the relatives mentioned in different descriptions. Our aim was to interlink the person references from the earlier data set to the later one. In total, there are 120,000 family relations connecting the students and their relatives, and 4,000 other relations, for example connecting a student with a teacher. The biographical data is enriched with 170,000 events, like births and deaths with events related to a person's career. In addition to people and event data, the entire dataset uses domain ontologies of, for example, places, occupations, family relations, and student nations. The place ontology with 2,600 resources is custom made for this project. The ontology includes historical place names from, for example, Karelia, Baltic countries, and Central Europe. The data has many references to small villages located in Sweden, which were extracted from GeoNames data service. The ontology of occupations contains more than 10,000 descriptions. One such a description contains often a place names connected with an occupation, for example Bishop of Porvoo, or Bishop of Turku. The occupations are linked to AMO, Finnish ontology of historical occupations, which is a Finnish extension of HISCO, Historical International Standard Classification of Occupations. The ontology of family relations contains not only the close relatives, like parents, children, and spouses, but also more distant relations, like in-law relatives or relations reaching over several generations. The data publication contains also some smaller, domain-specific ontologies for representing, for example, student nations, categories, and organizations. The category data was included in the source data. The student nations and organizations were both extracted from the text descriptions. For representing the biographical information, an actor event-based schema is used. The schema is based on the CIDOC CRM standard. In addition to CIDOC CRM, BioCRM is used for representing person roles and interpersonal relations. BioCRM has been developed and used in our earlier projects on Norsi High School Register and Biography Sampa. In the actor event schema, a person resource is enriched with events, which facilitates dealing with a possibly varying amount of data available for an individual person. The people in the register are represented as instances of the person class, and the mentioned relatives using the referenced person class. In the semantic representation, the resources of actor classes are enriched with lifetime events and relationships. Events, for example birth, death, or enrollment, are subclasses of the event class. Furthermore, the events are enriched by linkage to corresponding places, times, or occupations. Data service and portal. The Akatemiasammon publication consists of two parts. On one hand, there is the web portal for browsing the data. On the other hand, the data publication is available online on the linked Data Finland service platform, and a Sparkle endpoint is provided. Akatemiasammon is based on the Sampo model, and its portal has been implemented using the Sampo UI programming framework as an example of data service utilization opportunities in application development. The main entry page is depicted on the right. The web portal consists of four facet perspectives, for studying the data of the people, the places, the vocations, or the student nations. In the application view, people 1 can search for a specific individual or group of people for prosopographical analysis using an ontology-based facet search. The search facets are on the left and the results fill the rest of the page to the right. By default, the people in the results set are ordered by their degree of networking, for example, by the number of links to external databases, with famous students such as poet Elias Lönnrot, President of Finland Juho Kusti Paasikivi, and poet Johan Ludvig Runeberg. In facet search, the result set is filtered by making selections from hierarchical facets. The upper facet lists the organizations associated with the people from which the regiment horn has been selected, and the lower the student nations in which the people associated with the regiment horn can be found. Of these, the Ostrobothnian student nation has been selected, in which case all four people associated with the Horn Regiment and the Ostrobothnian student nation have been found through two facet selections. Each person in the dataset has a separate instance page or home page showing his or her biographical information in the traditional way, as well as related information and analyses based on the entire material and supplementary data outside the registers. Instance pages are presented in a table format where the left column lists the characteristics associated with the person, such as university enrollment time, vocation, and student nation. On the right are the values such as the time of enrollment on the 10th of February, 1822, and the vocations of lecturer at Porvoo High School, docent and author, as well as links to further information. People are linked to Wikidata and Biography Sampo. Wikidata links have been used to retrieve people's Wikipedia pages and possible photos of people from Wikimedia Commons. Furthermore, the tabs on the person instance page provide 4 different kind of egocentric networks, depicting for example the family or academic relations of an individual. This network in example shows a people connected to Runeberg by belonging to same organizations. By making choices about facets, you can also narrow down groups of people and explore them. With the facet options, tools for prosopographical analysis are available in the timeline, migration, map, and network tabs. The timeline tab shows the annual births, university enrollments, and deaths. The result in this example shows the charts for the total of 521 female students. The Migration tab visualizes the mobility and immigration of student. In the case of this example, the 597 Smolensk students with arcs depicting the life cycles. The blue end of the arc indicates the place of birth and the red the place of death, which is most often in the territory of present-day Finland, and the thickness of the arc reflects the number of people associated with the arc. By clicking on the arc, you will find related links to people's pages. The Map tab shows the approximately 3,000 locations to which students are connected by approximately 175,000 events. For example, clicking on a marker in Ireland finds 2 related people, the other being the famous Johann Gadolin, who later discovered a new element, yttrium. The Network tab allows to explore the internal academic network of a group of people specified in the facet selections. For example, the teacher-student network of 1,480 male students born in Helsinki. The Places view of the portal offers a similar facet search as in the People view, but now targeting historical places. You can search for places using the hierarchical facet or text search and see the search result as a table. For Finnish place names, the geographical data, for example coordinate location, alternative labels, and hierarchy of places, has been extracted from the National Land Survey of Finland's Place Name Register database, and from the ontology of the National Library's Fintofi ontology service. The most important source for foreign places has been Wikidata, providing also additional photographs and coats of arms. Finally, the earlier material contains plenty of references to places in Sweden, which were geocoded using data from the International GeoNames database. For instance, we can search the historical sites for those with the word university in their name. As a result, there are 16 universities from Finland, Sweden and Estonia and the rest of Europe with photos from Wikidata, such as the 7 German universities mentioned in the registers. The search result can also be visualized on the map on a separate tab. Clicking on a place marker opens a pop-up window with a list of the people whose events, such as death or career-related events, are known to have occurred at the selected location. A link in the pop-up window leads to the person's instance page for a more detailed investigation of the event. This example depicts the Map tab zoomed to downtown Helsinki, where you can find, for example, Helsinki Normal Lyceum. The placement of Norsi on the map is an example of the possibilities of linked data. Only textual mentions of the Normal Lyceum are found in the registers, but the open licensed information in Wikidata can also be used in Akatemiasammon. Clicking on the marker opens a pop-up window listing all 415 students and other school-related people found in the database, such as Ivar Edvard Wilskman, a school gymnastics teacher and professor known as the father of Finnish sports. Using the SPARQL endpoint for data analysis. For more complex analysis or more customized options, the results of a SPARQL query can be analyzed using libraries and different programming languages. Google Colab provides an easy way to write and run Python code online as Jupyter notebooks using a web browser, edit them collaboratively, and share results easily and visually. A document can consist of explanatory text snippets, code snippets that can be interpreted, and visualizations produced using Python code and libraries. This is an example of map visualizations using spatial data in the Yaski editor. In the universities in Sweden and Finland, the student nations were named after historical regions. and the students had to join the student nation corresponding to their own geographical place of origin. This map visualization shows how the place of birth correlates with the student nation. The maps clearly shows how students of, for example, Tavastia, or smaller nations concentrate on the corresponding geographical regions. The chart on the left depicts the average age of students with respect to the year of enrollment. The trend line shows how the age at enrollment has evolved during the years shown in the chart, with an obvious increase between about 1825 and 1850. The query itself requires just over 10 lines of Sparkle query language. This result has been visualized using a ready-made chart tool of YASGIT. The chart on the right illustrates the proportion of students whose father has also studied at the university. It can be noticed that in it, when grouped by gender, women have a higher proportion. This visualization was created using Python library matplotlib using the results of a relevant Sparkle query. This slide depicts the 5 most common occupational categories on a timeline. The curve on the top shows the total number of people in each category, while the bottom curve depicts the percentage. From the bottom image it can be seen that during the 3 centuries the proportion of religious occupations has decreased from 75 to mere 10%, respectively. The fields of public administration and education have had an increasing growth during the 19th century. The data set is rich with the family relations. As a chosen example of the family networks, we have picked a family line starting from Joseph Valerianus. 64 of his descendants have also been students at the university during the following 7 generations. In addition to the family relations, the dataset contains a network of teacher-student relations, spanning all the way from the 1640s to late 1800s. By network centrality measures, like PageRank, the most central person in this network is Henrik Gabriel Porthan, who has been the instructor or supervisor for more than 170 academic theses. He was a professor and rector at the Royal Academy of Turku, and a scholar sometimes titled as the father of Finnish history. The 2 other central figures are the university professor and bishop of Turku, Jakob Gardolin, and professor and historian Algorth Skerin. Discussion. Related work. Representing and analyzing biographical is a new research and application field. In 2015, the first Biographical Data in Digital World Workshop BD 2015 was held, presenting several works on studying and analyzing biographies as data, and the proceedings of BD 2017 contain more similar works. In bringing lives to light, analytic visualizations were created based on US legislator registry data. The idea of biographical network analysis is related to the 6 degrees of Francis Bacon's system that utilizes data of the Oxford Dictionary of National Biography. In our case, faceted search can be used for filtering and studying target groups. Work on Akatemiasammon is continuation to our earlier biographical linked open data systems on Norset Alumni Register, the US Congress Prosopographer, and Biography-Sampo. Why is data literacy needed? The entities, concepts and relationships identified from the register texts form the basis for links, search functionalities, data analysis and visualizations in Akatemiasammon. The aim of here is to facilitate the researcher's work in reviewing and researching register material by automatically extracting interesting references, links and visualizations whenever technically possible. An example of the distant reading of digital humanities. Using semantically linked, rich data easily creates a misconception that the data and links would be complete and the gaps in the data would be flawed. It must be recalled that the extracted knowledge is based only on the available data. Acknowledgements. We will thank Ejikotavori and Veli-Matti Autio for authoring the original data publications used in our work. This work is related to the EU project in Tarvia, and the EU Cost Action Nexus Lingurum on Linguistic Data Science, CSE. IT Center for Science has provided computational resources for the work, for example the National Server Infrastructure Hosting LDFE. I will now thank you all for listening. More information about the project is available at the web page of the Semantic Computing Research Group.
Lopuksi vielä lyhyt yhteenveto. Leonardo da Vinci on sanonut, opin näkemään älyä, että kaikki liittyy kaikkeen. Tämä viisaus on kaikkien Sampo-järjestelmien takana, jotka perustuvat datan linkittämiseen. Kiitos mielenkiinnosta Akatemiasampoa ja työtämme kohtaan.